In question 10, they're telling us that the angle between any pairs of lines in Cartesian form is also the angle between their normals. So I'm given two different lines, and I can find the normal of that line pretty quickly, actually, the normal 1. I'll call that line 1, -3. If I talk about this one, we'll call that normal number 2. Its direction is 1 and 2. Well, part A doesn't ask me for angles. It actually asks me to sketch the lines. So if I want to sketch those two things, how can I go about doing that? Well, to sketch a line, I kind of need to know a point on the line. So for line 1, what happens if I make the y part be 0? So 0 and something. Can I figure out the part that goes with it? Well, of course I can. I end up with x minus 3 times 0 plus 6. Or in other words, x equals -6. So I know -6, 0 is the point on the line. If I do the same thing for the second line, again, we'll make our y be 0. I can do x plus 2 times 0 minus 7 is 0. In other words, x is 7. Okay. Got myself some points. What else do I want to do? Well, I need some directions, right? What's the direction of the line? Well, line 1, if I take the normal and flip it back to the way it was, I get a direction of 3, 1, which means I go right 3 and up 1, right 3 and up 1, right 3 and up 1. And I can find the coordinates of the points if I want to very quickly. So this would be like -3 and 1. This would be 0 and 2. This would be 3 and 3. Okay. I do the same thing with the other one. So there's a number in there. My direction vector for it, if I flip those around back that way, 2, -1, means I go right 2 and down 1, or maybe I want to do that instead. So left 2, up 1. So 5 and 1, 3 and 2, 1 and 3. And then I get myself my two lines. Okay, I've sketched those using a point and a direction. If I want to find the angle between the two lines, well, I've got two ways I can do it. I can use my direction vectors, or, as they told us in the question, I can use the Cartesian vectors. But either way, I'm going to have to use the dot product idea. So the cos of my angle should be the dot product 1 times dot product 2 over the magnitude of each dot product. Sorry, each normal vector. And I could have used the direction vectors also, because their angles can be the same thing. In our case, what do we get? We get 1 times 1 is 1. We're multiplying these things together, right? -3 times 2 is -6 over the square root of 1 squared plus -3 squared times the square root of 1 squared plus 2 squared. If we simplify all that stuff, we end up with -5 over root 10, root 5. That's what cos theta is. So theta, if we punch in our calculator properly, would come out to 45 degrees. And that would be our acute angle. It also asks us for the obtuse angle. So the obtuse would be 180 minus 45, or in other words, 135 degrees. If you take a look at your picture, you can sort of tell 45 and 135. I'll go about there.